We are wrapping up chapter 3, and I wanted to go through the review sheet with you. By now we've seen this picture so many times that you should know that the interior angles are angle 3, angle 4, angle 5, angle 6. They don't have to be in any particular order. Of course, the exterior angles are angle 1, angle 2, angle 7, and angle 8. When we want to name pairs of alternate interior angles, those would be like angle 3 and angle 6, angle 4 and angle 5. Notice I have the angle symbol. Two pairs of alternate exterior angles, those would be angle 1 and angle 8, angle 2 and angle 7. Corresponding angles are like 1 in, 1 out. So those would be angle 1 and angle 5. Similarly, angle 2 and angle 6, angle 3 and angle 7, and angle 4 and angle 8. And then finally, vertical angles, which we've known for a long time, are angles 1 and 4, angles 2 and 3, angles 6 and 7, and angles 5 and angle 8. So those are the names of our angles. If we go on to a harder picture where we've got different lines, like two pairs of lines, so now I look at angle 3 and 9, that's alternate interior, or A. Angles 8 and 13, 8, 13, those are same side interior, so that's D. 5 and 7 there are vertical angles, F. Angles 1 and 2 are right next door. They make a straight line, so they're G, adjacent supplementary, or a linear pair. 10 and 16 are back again to alternate interior. 1 and 12 are same side exterior, D. Actually, I feel like I did a mistake, didn't I, for 8 and 13. That should have been same side interior. Back to that one, sorry, should have been B. Now I'm on 2 and 10, those are corresponding. 6 and 16, those are alternate exterior, C. 5 and 13, here's 5, here's 13, those are corresponding, E. And then finally 13 and 15 are vertical angles. We know our relationships really well. We know alternate interiors are equal, corresponding are congruent, same side are supplementary. We know that vertical angles are always equal, and we know that adjacent supplementary, of course, are always supplementary. You're very familiar by now with the checkerboard. So if it starts here at 50 degrees, 50, 50, 50, 50, and then if I subtract from 180, 130, 130, 130, 130. Similarly here, I would have the 150. Remember that all the obtuse angles are equal and all the acute angles are equal, 30, 30, 30, 30. For the infamous double checkerboard, where everything is parallel, we just kind of zigzag through this double checkerboard of 140s. And if I subtract that from 180, all the other angles here are 140. Excuse me, 140. The last one, 23, is a double checkerboard, but it's a little different because it has two different pairs of numbers. Here we've got 80s and 100s on this side, 80, 100, 80, 100, 80, 100, whereas the other side has 70s and 110s, 70s and 110s, 70s and 110s. Now we look for hidden checkerboards. So we see a checkerboard here with the 30, 30, 30, 30. And then if I subtract from 180, again, I've got 150, 150, 150, 150. I like to put that all in before answering that angle 1 is 150 and angle 2 is 30. On the other side, I start with a 60, 60, 60, 60. Angle 4 is 60. And if I subtract from 180, I get 120 for angle 3. I don't have to fill the whole checkerboard in, just enough to answer the question. In a parallelogram, we learned that opposite angles are equal, so that makes angle L 120, and that the angles next to each other add up to 180, so 60 and 60. This is a trapezoid, so I've got same side interior angles are supplementary. 90 and 90 add up to 180, and on the other side I have 130 and 50 that adds up to 180. Here I've got Z angles, so in particular alternate interior angles make angle 2 51 and angle 1 42. There's a question exactly like 27 on the test. Then with the parallelogram here, let's see, so this one here gives me, again, opposite angles equal, so 50, 50, and then 130, 130 here and here. 130, 130. Similarly, 125, 125, and if I subtract that from 180, I get 55, 55. 55, 55. I'm going to put a star by 30. There is one like that. I know that this is a really tough one. You've got this hidden Z inside here that tells you that angle 1 there is 15 degrees. What I like to do with this one is draw the parallelogram blank. So I see the 130, 130. The opposite two angles would be 50 and 50. So in particular, angle PLA, this entire angle is 50. To find that little mini angle 2 is going to be 50 minus 15, or 35 degrees, and that's going to match angle 3 there because those are alternate interior. I know that's a tricky one. So I have another one real similar to it here with song. So angle 1, let's see, here I've got this 80 degrees, so if I redraw it, I'm going to have 80, 80, 100, 100. So in particular, angle SGN is 80, and then angles 4 and 3 are 100, and then angles 1 and 2 are going to be those Z angles again. Angle 1 is 30, and similarly, angle 2 there is 50. Okay, and we know that that's a harder one. Here again, I see these Z's making angle 1 25, backwards Z makes angle 2 50. I gave a hint, there's 180 degrees in a triangle. So if I've got a 50 and a 25, that's 75. So that leaves 105 for angles 3 and 4. And because I have a straight line here, I subtract 180 minus 105, 75. I know there's one like number 33 on the test. This is a little bit easier one where you just have a Z there to make the 75. Backwards Z to make a 70 for angle 3. And write them in. And then here I've got a straight line, so if I subtract from 180, angle 4 is 110. And here I've got 3 angles, so that's 145, leaving me with 35 degrees. As a double check in this one, I have a triangle that also would add up to 180. Then I'm giving you one of each type of angle. So here, these two angles are a linear pair. I'm just going to abbreviate. So if I subtract from 180, I get 60. These two angles are corresponding, so they're congruent, 120. These two angles are vertical. Vertical angles are equal, 120. These are alternate interior angles. I just abbreviated. Those are the same, 120. And then these two are same side interior angles. They're supplementary, 60 degrees. We use those relationships here. So if you look at these two angles, they are same side interior. They are supplementary. If they are supplementary, they add up to 180. I'm just going to add these up here to 32x plus 20 equals 180. So 32x equals 160, and if I divide, I get 5. These are alternate interior angles. Those are equal. So 14x plus 2 equals 16x minus 8. And then those I subtract, and to get 2x equals 10, so x is 5. These angles here are corresponding are congruent. So 3x plus 40 equals, I can't read it, what was it, 9x minus 8. So if I subtract there, I get 6x is 48, x is 8. These angles are opposite angles of a parallelogram, therefore they are equal. So I have 4x minus 2 equals 74. 4x equals 76, and then if I divide that, I think it's 19. Yeah. These are same side interior. They are supplementary, so they add up to 180. Common thing we see is people will circle supplementary, but then make them equal to each other. If you circle supplementary, you have to add them up to 180. And these are actually complementary angles. These add up to 90. 2x plus x equals 90. We've had these for a while. 3x is 90, x is 30. Symbol for parallel, symbol for perpendicular. We're looking at the picture and saying which angles are these. These are corresponding. I'm just going to abbreviate. This is not enough proof, so this is just makes those lines a straight line. That doesn't make lines parallel. This is alternate interior. These two are same side interior, and vertical angles are not enough proof to show that lines are parallel. To show which one is which, looking carefully at the numbers, the 70 and 110 add up to 180, so that makes those two lines parallel. The 30 degrees makes these two lines parallel, and then those 88s make the X parallel to Y. Line Q is parallel to line R. I'm just going to use the symbol. Line P is perpendicular to R and perpendicular to Q. And P and S are just intersecting, so there's no symbol for that. So I'm just going to write the word intersecting. When I say segments parallel to TZ, here's TZ. So if I use, let's say, a light blue, these three segments are all parallel to TZ. Notice I'm using a segment bar, and it doesn't matter the order of the letters, but those are the same ones that are parallel. Ones that intersect or cross TZ would be something that would have either a T or a Z in the answer. So ST, UT, WZ, YZ. And then finally the skew ones, those are the kind of leftover ones, like VU would be skew, so would SV be skew, so would WX, and so would XY. On the test, you only have to name, I think, one segment. All right angles we know are congruent to each other. If two lines are perpendicular, they form four right angles. If two lines are parallel, they're in the same plane and they do not cross. If two lines are perpendicular, if they form a right angle. Two lines are skew if they're not in the same plane. And two planes are parallel if they never intersect. Last thing is to draw a line through Z parallel to JK, so something like that. Through Z perpendicular would look like this. If a line is a point on a line, there's exactly one line parallel, that's kind of that one, and then one line perpendicular. Last one is looking at W and K, those are parallel. It looks like in this one they are skew. Here they intersect. U and W, those intersect. And M and N are skew. I know I went quick, but I was just trying to get them all in. That is the Chapter 3 review sheet.